Let's pop back to the slides very quickly and we'll motivate. How do we go from prompt engineering to now like this RAG, retrieval augmented generation land? Okay, so now we've got some new entities in our chain of events that's leading to this response and its corresponding relevance to the end user. So similar to before, we have a prompt. Obviously, that's high relevant. That's what the user is typing into the machine. Then before, we just had this big blob. We just had this big generic model blob. The prompt was going directly into that thing, and there was no extra like data being mixed in. The new thing that RAG is adding is we see we have a little database here, and we're going to retrieve something from the database. That's the R in RAG, and then we are going to augment the prompt with that thing that we retrieved, and then we're going to use that thing to generate the response that the end user sees, with the hope of like us injecting some relevant data into the prompt is going to like have a big effect on the relevance of the response.
And maybe one point to make here is, as we'll see later, another way to inject relevance is fine-tuning and that type of stuff, but that requires significant compute and time, whereas retrieval augmented generation is a way of doing it without requiring retraining, right, Eddie?
Yeah, that's right. That's right. We're still using models because we're putting vectors in particular into this like database looking thing.
So is that a vector database?
Yeah, it could, well, okay, that term has become like kind of like an industry term, which we can talk about this in a little bit maybe. It's just anywhere that you can store vectors. So I guess in the like very literal sense of the term vector database, yes, that is what it is. It's like we take embeddings from an LLM or any kind of language model, and then we put them somewhere. We put them in an index is what the tools typically call it.
Great. Let's do it.
Sweet. So yeah, we're kind of like going into the library, finding stuff, breeze through the slides here. So this slide actually does explain exactly what it is, Hugo. What I was just talking about is like we have structured data. We're just trying to put it somewhere like that it's indexed, that it's ordered. And then when we have a new example, like we see in the second row, we can make one vector and then we can do some kind of search pattern. Very old, like tried and true data science method here. Like the way that we can search is like very mathematically well understood. Cosine similarity works really good. It's what OpenAI suggests when you use their embedding API, so on and so forth. That's what we're going to be doing here. Any questions before we dive in?
No, super excited to dive in.
All right. Cool. So as I mentioned, there's a bunch of different vector database providers in the market right now, some open source, some closed source. The one that we're going to be using today is called Pinecone. This is closed source, and we're going to kind of show you like the process of getting your API key and kind of like going through the whole end-to-end chain. So similar to before, I'm going to have to connect here and then run my pip install. And then we're going to need a Pinecone API key. So to do this, let's go to Pinecone. No, actually, this is less helpful because I've already been on the console. Let's do like the from scratch way. So if you go to Pinecone, the quick start page, you'll see like big sign up free button. If we click on these things, I can continue with my existing account, but that's also the flow you'll use to make a new account. And the end goal of what we're trying to do here is make an API key that we can use. I've already got one, so I'll just copy that one. And then to be complete, let's just delete this index because we're going to recreate it in this example, just to kind of see the full thing. So I'm going to copy my API key. And again, like Hugo was saying before, like not a great practice just to be pasting your API keys and variables and stuff like this, but of course, this is just a demo. And then the other thing that you're going to want to set is you're going to want to take note of the environment in Pinecone here. These are kind of like availability zones, maybe if you're, or regions, excuse me, if you're familiar with AWS terminology. Cool. Okay, so now we've got our setup. We've got our Pinecone client installed. So we should be able to go ahead and initialize. Okay, great. Now, we are going to be using this RAG tools that we created. And this RAG tools is coming from a repository that we put together at Outer Bounds with our collaborator, Federico from Stanford. I'll go ahead and show you this. It's in the RAG demo repository. We're just installing it from this GitHub repository. We did a whole blog post about this, so if you're curious about details, definitely check out this post. In this repository, it has a bunch of stuff, and that's where we're getting this tool. And basically, it just provides a simple wrapper around creating embeddings and then a way to parse specific data. Cool. I'm realizing now too that I forgot something interesting up here that we're going to need. We're going to need both the index name and the metric. So let's just go ahead and define these variables right now. Okay. Now, what we want to do is basically take a couple chunks of text and put them into a vector index. So super high level concept. Hugo, any questions or anything that you'd want to add before we just go like show the loop of like getting data into Pinecone and then retrieving it?
No, I'm good. I'm really excited to see how this works, actually.
Okay, cool. So we just got a list of Python strings. Hello, Gen AI friends, Metaflow, blah, blah, blah. Lots of people, machine learning, XYZ. Cool. Now, just like before, we went to Hugging Face and we found a model. This time we're using the sentence transformers kind of repository, this like place where you can search for, sentence transformers specifically is like quite good for embedding models, is why we're using it here. And this is the name of the model that we're going to use. This object is a little wrapper that's in the RAG tools thing, but it's like a very thin wrapper around like the Hugging Face API for doing this. So let's actually just go ahead and do these two together. We're going to make the encoder, and then we're going to encode these 3 text samples. So we'll get 3 vectors as an output. So now we see Hugging Face doing a lot of action, kind of downloading the model, and then we've already produced our embedding. So if we print this out, we'll see it's just an array, and we can do a shape. We should see 3 rows. And then the other thing that we see is there's 384. So these are like not the dimension, essentially. So let's actually just set that as a variable, which we'll use as we instantiate the Pinecone index. So now earlier you saw me kind of delete an index in here, so we have no indices. And by the way, the reason I did that, in addition to making the demo more interesting, is that you only get 1 free index on Pinecone. So just know that if you're going to make the free account, you can only do 1 of these things at a time for free. Now to instantiate a new index, which like this is that database, that purple database picture that Hugo and I were talking about on the slides. All you need to do is run 1 line of code, create the index with our index name, specify the dimensionality of each vector. So how many numbers are in the list of these embeddings for each string, and then the metric, which we chose the cosine similarity metric, which is like nothing, it's like not a special thing really. It's you can just read about it if you're not familiar, probably on like Wikipedia or something's the best place. Like very simple kind of dot product formula for like comparing how.
Yeah, scroll down though, because it's way easier to, you don't need the math. It's way easier to see in a figure if they have a figure.
Let's have a picture here. So I mean, just go to the
Anyway,
images.
oh yeah, no, yeah, exactly. That's a
Oh
calculator. That's amazing though.
yeah,
It's the
right.
angle between things. You have some embedding when things are close, they point in the same direction. When they're not, they point in opposite directions.
Totally. Cool. So let's see what's going on with our index. How are we doing? Can take a minute to create. So you see we're still initializing. Eventually this thing will turn green, and then that Python code that we're running will be done. Let's see. Oh, I was going to ask a question, but it already turned green. So let's keep moving. All right. So we see that it's existing now. So now we're like freed up in the Python terminal again. Now that we've created the index, we can actually fetch it and use it as a Python object. So all you need to do is pass the index name. And then this operation is where we're actually going to put these embeddings, these vectors, inside of the vector index. So you can see like we're doing this very manually in this case, just for education purposes. But the call that we're making to the index is called upsert, and we're just putting in a list of vectors, each with an ID that we're specifying. So like one interesting thing to think about is like maybe this is an index or some other like key that you could use to connect to another database, or maybe you're storing a foreign key in this metadata to some SQL database or something like this is interesting to think about from an app design point of view. But let's go ahead and just put all of these embeddings into the index now. You can see that happens super fast. And now in this cell, what we're doing is kind of like, okay, that all happened offline, maybe like that's all running in some workflow in the background, which is what we'll get to in the next lesson. But now we're at like runtime. We're in the app. So like Hugo comes into our new chatbot powered by this RAG system, and Hugo's like, what does Metaflow do? So this is our query. And then remember, we're going to use ChatGPT. So it's like we could also maybe ask a question that's like totally like ChatGPT would have no idea about, but then the data is actually in these examples is like when RAG is working well. But in this case, we're just going to kind of like show the mathematical process first. Now what we do is we use the same exact encoder as before. So we have kind of this parity between what we put into what we upserted into the database, and then the way that we're producing the vector now at runtime for the query. So just like before, this vector is just a big list of numbers. So this one will have shape 384, where remember our embedding had shape 3 by 384. And now what we're trying to do is create matches. So like since we only have 3 examples in our database, the top K being 3 isn't very interesting. It'll just return everything. Let's go ahead and return the top 2 of the 3 responses. And we're just going to run index.query is the Pinecone API for this. Very quickly, we get our matches. We'll do it just a bit of unpacking of the response in Python. And then we can go ahead and see that now we get in this response, we have a list of dictionaries. In the first dictionary, we can see a bunch of different information, including the ID of the vector from the database, the score. So this is the cosine similarity, as we were looking at in the pictures on Google Images. And then since we included the text in the metadata, we're actually also returning this as well. So that's basically the end-to-end loop. And I'm going to go ahead and delete the index now. But Hugo, do you have any questions or anything?
Yeah, let's just look at the scores and see if it makes sense to what we would think, right? So to be clear, cosine similarity varies between, is it -1 and 1?
Yes.
Because it's a cos of.
Yes. Oops.
0 and 1, sorry. Yeah, of course, because we're taking absolute values. Okay. So great. So 1 means.
Wait, didn't you say? Oh no, you said yeah. It's not. You're right. It's 0 to 1, not -1 to 1. To be clear,
Yep.
Right.
So what are we getting cosine similarity to here?
So we're getting 0.24 for the second entry and 0.61 for the first entry.
And so what are the terms there?
Remember, our query was what does Metaflow do?
Yeah.
We would expect this one to be, I mean, on a relative scale, it's like maybe 3 times more relevant is like what the cosine similarity metric is telling us in like very loose terms. That this first response is maybe 3 times or so more relevant than the second one relatively. Let's look at the second one first, the one that's supposedly worse. Lots of people recognize machine learning systems require robust workflows.
Yep.
This is the input text that was being embedded.
Yep.
And now one that this retrieval mechanism is saying matches better is Metaflow helps you build production machine learning workflows. So in response to this as a query, like I would say that that's pretty reasonable.
Yeah, absolutely.
Ranking.
Yep. And I think your heuristic around it being 3 times is pretty good. I don't think it is actually linear though.
Yeah, it's definitely not linear.
Yeah,
that's a good call out. Is like that's mathematically not say.
So yeah, but this is good. So what we're seeing as we're doing a vibe check here essentially is that Metaflow helps you build production machine learning workflows is more relevant to what does Metaflow do than lots of people recognize machine learning systems require robust workflows. Okay, so that's nice. It's working.
Yep. Cool. Now, in
Awesome.
the rest of this notebook, oh yeah, go ahead.
No, we're good.
Cool. In the rest of this notebook, now what we're going to do is instead of just having 3 hand-coded examples, we're going to extract a bunch of different text chunks from Metaflow's documentation.
Mm-hmm.
So that's another thing that we built in this RAG tools thing, is just a way to parse the structure of the markdown files that are metaflow.com or metaflow.org and outerbounds.com. So that's what we're importing here. These are like custom tools for parsing. Like they're useful for general GitHub repositories that are written in Markdown, or you can write your own parsers. That's another thing LangChain has, by the way, is they have a bunch of different parsing tools to try out. Yeah, let's just keep rolling here. Then we're going to load these all up as a data frame. So just to be really clear about what we're doing, we're crawling this repository. This is what becomes docs.metaflow.org. So you'll see all the columns on this left-hand side here. These are going to match the different folders inside of the docs in Metaflow's documentation repo. And that's the thing that we're crawling here. And then the result of this crawl is basically we've chunked into a data frame by the headers in the documentation pages. So we kind of have like the H1s, the H2s. These are the different chunks of text. And then the thing that we're going to embed here is this contents column. So if we just look at that, and then maybe just like pluck the first one, we can see that we get this like mix of like what's just directly coming from those markdown files. So we see a little bit of HTML in here. And then just kind of like the string pattern. Cool. So this is going to become this is our data set basically. So we'll do a little bit of filtering. It's kind of like normal data munging, just kind of getting rid of the ones that have very few characters, very few words. And then we're going to get into the actual embedding workflow. Basically the same thing that we did above. So I'll just like kind of blitz through this because it's not that different than what happened before. Feel free to pause me, Hugo, if you have any questions or comments on any of this.
For sure, we're good.
And then we'll do the longer part here. So before, like we embedded and it was almost instantaneous. So we didn't even really notice anything was happening. But it's important to remember that like, we're still using a deep learning model here to embed these documents. So we see now like even getting up to like there's maybe 400 rows after the filtering in this data set. It's like already becoming a non-negligible amount of time where we're just kind of sitting here waiting. And you can imagine if you had a data set of like 4 million documents or something instead of 400, this would become like really, really slow to do this all sequentially, like how it's happening right now. So that's just like to kind of like foreshadow like one reason why you might want to think about like how do you break these systems up and parallelize them or something along these lines. Okay, cool, but that's done relatively quickly. In our case, it really doesn't matter. We can do it all locally. Again, we have the same dimension. And let's just check the actual shape of the embeddings. So again, 384 for each vector, and then we have 441 vectors now. And this will be matching the shape of our data frame. Cool. Okay, so same thing as before. We'll just reinitialize Pinecone. We'll pick the Metaflow documentation as our index name. And we will do, should we try a different metric, Hugo? Maybe we can shop for new ones.
Yeah.
Not even fully aware. Okay, so the 3 that they have. Oh, so actually, you were correct earlier. In fact, Pinecone is normalizing the cosine similarity in between -1 and 1.
Yeah. Okay. Yeah.
So it's like
That's an yeah.
By default, I think we were correct in the 0 to 1.
Yeah. And that's an implementation detail. I just wanted to get kind of a rule of thumb for whether it was working or not. So that's totally cool.
Yeah. So the 3 that they have apparently right now, and like all these different providers have many different flavors of these metrics and things to explore. But is there any of these 3 that you'd want to try out? Maybe the Euclidean or the dot products?
I'm easy, man. I think if the point is to just demonstrate that we can switch out a different metric, either is good.
Fair enough. Fair enough. Cool. Now I'm just going to go ahead and skip this conditional block because we know we deleted the index. Go ahead and recreate. So now going back to our, I deleted the app.pinecone. So now we'll go ahead and see this thing is initializing, creating our index in Pinecone. And then we're going to go through the same process of just upserting the documents, searching the index, and now we can start to get into more specific questions about Metaflow. So like while this index is creating, maybe we can do a little bit of a detour and think about like how would ChatGPT respond to this question? Just totally like if we wanted to have ChatGPT in the Metaflow documentation somehow as a chatbot, how would it respond if a user asked this question if we didn't modify it in any way with RAG?
Yep.
So to
Great
see
question.
this, I'll get rid of my like GNOME prompting, and we'll just go back here.
I'd be interested to see how it does it with the GNOME prompt, but no, I'm
Yeah,
just
I mean that would it wouldn't be a fair analysis, but it would probably be more fun, which is like such is the life of a data scientist, trade-offs.
a GNOME data scientist.
Ooh, now you're talking my language.
GNOME
Okay,
language.
so basically like kind of what we would have expected here. Like it didn't even know that I was referring to Metaflow in this question, which like why would it? If like that's not ChatGPT is not indexed to only talk about Metaflow or something. It just gives this like generic BS response that's like kind of useful to like understand how Conda behaves in general. But if a user asked that in the Metaflow documentation, like that would be pretty bad to give as a response. It'd be like borderline useless.
It's also useful to know that you got to write YAML, dude.
Yeah, right. That's a whole nother level of pain. Okay, now where was I in this notebook? Yeah, okay, so we've created the index now. Yes, so one thing that we're going to do now is we're going to use that data frame. So this guy, we're going to use the indexes from this data frame as a way to pass metadata into the Pinecone index. So like what this is really setting up is that not only is Pinecone going to return the relevant context, it's going to return the index so that we can get like a small data frame of those retrieved results. And one thing that you'll notice in the columns of this data frame is that we also have this thing page URL. So if we look at the page URLs, one of the reasons that we would want to do this is now we have a specific link to each chunk of text because these are all indexed by the headers in the markdown, remember? So like this is a naive way to do this. There's definitely more sophisticated ways. And maybe another reason to look at tools like LangChain is they have this stuff built in. But what you'll see is like this, you can now like return the relevant results, give that to ChatGPT, but then you can also give it like actually like cite your sources and like point people to this as the thing that you kind of conditioned your generated response on. Okay, so I'm just going to keep moving and stop chattering because this is already a very long video. Okay, so just creating the vectors, and now we're going to upsert them into our database. Super fast again. And now we're going to take the same query that we typed into the ChatGPT. We're going to use our template from LangChain, just like we saw before when we did the like little Google Translate clone. Now we have our chat prompt, like chat. And we'll get a response. And again, like we're not doing anything special here. So we should see something like what ChatGPT said before. Like we're not retrieving anything from the database, not doing anything interesting yet. So yeah, basically we see a bunch of stuff about the YAML files, Hugo's worst nemesis. We see a little bit about prefects. Like again, if you got that in the Metaflow documentation, it'd be a little bit confusing, but maybe a little bit better even than the
It's
chat.
prefect and Dask, actually. Interesting.
Yeah, interesting combination. Yeah. Cool. Now, how do we actually use the stuff that's in that data frame?
Yeah.
Like, how do we actually make this better? So let's set k equals to 5. So this is like the number of things that we want to retrieve from Pinecone every time we do this query matching. And then this is the exact same
And
code.
why 5? Like, what's a rule of thumb for choosing K?
Great question. This is like application design in my point of view. Like there's some data science to it, but it's also like one way I think about this is like there's this tool that I really like called Perplexity AI. Are you familiar with them?
Can't recall. Oh, yeah. Yeah, I am.
Yeah, it's not like super different interface, but if we ask it like how do I use Conda with Metaflow or something, it one thing that I like that Perplexity does is like Bing also is doing this, and like ChatGPT increasingly has this functionality too, but they're very much like indexing on like they're doing a search process that's like somewhat like Google to index the internet and then give you actual like cite your sources kind of vibe here. Um, so like that's why I'm picking a number that I think would be reasonable for like how many sources do we want to do this on
Okay,
is basically how I'm thinking about it in this context, but it's
great.
very app dependent is really my answer. Do you have any thoughts as I type this out and kind of let it run? Like, what do you think would be a good heuristic or rule of thumb?
I think, as you say, it depends on the use case, but I think in all honesty, unless it's a really complex thing, 10's too much to start with. 1's probably not enough. So then picking something between 1 and 10.
Yeah, yeah,
And 5 is between 1 and 10, and it's in the middle there.
that's true. That's true. All right, so I'm just doing a little post processing now, getting the indexes into the data frame. So we see that we've now got 5 indices. So these are the most similar things returned from Pinecone. And let's actually turn that into a little data frame. So now we have that thing that I was talking about, basically. We have 5
Very
chunks
cool.
of text. We can shove this into the prompt that we give to ChatGPT, and then we can also tell it, here's the URL, like use this as a way to like refer people to a real source that's not you generating tokens,
Yep.
essentially. Sweet. So now let's just to complete this loop, I'll do this part super quick because I think people that are still following along probably get this
Yeah,
by
and
now.
just as a little teaser, we're about to get to, actually building live production systems with all of this stuff. So
Exactly. So stay tuned, but like just wanted to like complete this train of thought because like we're not quite done with what you do with this context now. Like a really important, this is actually maybe the most important thing to think about as an app designer is like how do you now use the 5 results or the K results that you've retrieved in the prompt? This is like a mixture of like data science research, app design. How does your like product actually interact with your customer's experience? Many different moving parts here. We're still using that kind of like LangChain-ish pattern. Well, no, we're actually using LangChain still. So I shouldn't say LangChain-ish. And now what I'm doing is like this loop in particular is how I've decided to design this app to construct the context, where I'm just looping through the rows of the data frame. And then I'm going to be having this like, here's the context, and then here's its URL. And then I'm just going to be telling the model, like, do what you will with that, essentially, based on what's in that system message that I typed in above. And I get the template for the user query. Now we'll reinstantiate our chat prompts. Just like before, we have the system message, we have the human message. Get the chat object, and then we will do the loop. So now this is actually calling OpenAI behind the scenes. This is kind of the LangChain-ism of it all. Same thing that we did before. And then we can print our response. And now hopefully this thing is actually relevant to a Metaflow user who types that thing about Metaflow that ChatGPT had no reason to know is about Metaflow until we did RAG. To specify conda dependencies in your flow, you can use the @conda decorator. The decorator allows you to make specific conda packages available to individual steps in your flow. Here's an example of how to use the conda decorator, blah, blah, blah. So it's actually writing Metaflow code now. It knows that we're talking about Metaflow. It's correctly identifying that this is the way that you say like things from Metaflow. Like this specific piece of text is almost surely actually from the documentation itself. So yeah, that's basically like closing the loop on this kind of like initial foray into RAG. Any
awesome.
thoughts, Hugo, before we keep rolling?
No, this is great. And an exercise for the reader or the listener or the learner or the viewer, the watcher, is we've recently released our @PyPI decorator, so you can play around with it and see if you can answer the question how to do all of this stuff with pip. And this is one of my favorite parts of the Metaflow story. Very much talks back to our production deployment and making sure all your cloud workstations are equipped with the same software as your local workstations, that You can use merely a decorator. You don't have to write any YAML or anything like that to specify what packages you want for each step in your workflow, or you can do it at an entire workflow level as well. Don't want to go into that too deeply. Well, that's one of the many things that I love about Metaflow. I mean, I wouldn't say it quote unquote 100% solves the dependency management story, because if it did, well, you know, that's flying to the moon, really. But it very much in my daily work with dependency management.